We are starting chapter 4 today, which is all about quadratic functions. And our first section, we're talking about quadratic functions and transformations. We keep coming back to them, and we will keep coming back to transformations throughout the year. But all about quadratic functions for now. Remember, parabolas are symmetric. Parabolas are quadratics. And the fact that parabolas are symmetric is pretty important. Now, hopefully you guys can kind of remember what our parent function for our quadratic looks like. Our parent function was y equals x squared. And I'm going to make a sketch here of what our parent function looked like. We had our vertex was at 0, 0. And then we had 1, 1. And 2, 4. And here's my parent function. All right, so some things. I called this the vertex. We've used that word before. Our vertex is at 0, 0. And then coming back to the fact that parabolas are symmetric, there's one other thing. So if you think about how is this parabola symmetric, how could I fold a paper in half and have both sides be the same? Well, this vertical line right here. And you might have heard this called the line of symmetry before. We are going to call this the axis of symmetry. Now, how would we write an equation for this line? How would we write an equation for our axis of symmetry? Well, it's a vertical line. Vertical lines are in the form x equals something. And what is our x value? Well, our x value is 0. So the axis of symmetry for our parent function, y equals x squared, is x equals 0. And when we were learning transformations, we learned how our horizontal translations, our vertical translations, our reflections, all of that work with a certain parent function. We worked with our parent function here, y equals x squared. We also worked with absolute value. Now, in general, all of those transformations go together to form what is called vertex form for quadratics. And vertex form for quadratics is y equals a times x minus h squared plus k. And this is nice because if we think about h and k values here, h and k tell us our vertex. And people always ask me, do we really have to remember y equals a times x minus h squared plus k? What a means, what h and k mean? My answer is, guys, this is transformations. Whatever this h value is, that affects how our graph moves left and right. So on the inside, it affects left and right. This a value here, if it's negative, it would reflect over the x-axis. Whatever that number is, it's either a vertical stretch or a vertical shrink. And then k is our translation up and down. So if you remember this form, that's handy, I guess, but really it's transformations. So hopefully it kind of makes sense a little bit too, that our vertex is HK. because that affects how our graph, how our parent function moves left and right, and then up and down also.